Anyway, welcome. Thank you very much for coming. This promises to be a very, very interesting hour. We do have a whole hour, which is very exciting, as to explore, say, challenges for SoC designs for the next kind of 2, 3, 4 years, which is going to be a time of great change. It's going to be very interesting. Just a little bit about sort of who these guys are and why they're here with me today. They're part of a program called the ARM Approved Design Partner Program, which we actually announced exactly a year ago at DAC last year here in Austin. It started with just 4 members. Pleased to say that it's grown since then to 7 members, literally representing a worldwide distribution of SoC design expertise, which ARM has audited and checked out and is very, very pleased to recommend for new designs. So out of the 7 design partners in the program, I think all of them are here. They're participating in various panels. We'll be very pleased to have 4 of them here to consider this topic today. So I'll tell you a little bit about each of them as I ask them up. And then I'll ask them to introduce their companies and just give a little bit of background about who they are. And then we'll get the discussion going. So first of all, Elias Lozano, who is Senior Director of Business Development and IP Solutions for Open Silicon. Elias, if you'd like to come and join us. Elias has been in the industry for over 25 years, holds a master's in electrical engineering from Washington State. Welcome, Elias. Mr. Pascal Barioulet. Thank you, Pascal. Pascal graduated with a master's in microelectronics from Montpellier and joined Elsys Design in France at its creation in 2000. He now leads the business operations for Elsys North America. So welcome, Pascal. Thank you. Mr. Bogan Bizic. Mr. Bizic joined HDL Design in 2002. He holds an engineering degree in electronics engineering from the University of Belgrade, representing HDL Design House. Thank you, Bogan. And finally, Ambar Sarkar, who is the chief technologist at eInfoChips. He's over 20 years of experience in the industry. Was given the Key Contributor Award by Accelera for his contribution to UVM. Congratulations. He has a PhD in computer science from University of Virginia. So, ladies and gentlemen, please welcome the panel. As I say, I'd just like each of you just to take a couple of minutes just to introduce your company and the particular take that you have on the industry. So, Elias, if we can start with you.
Thanks. Can I say a disclaimer, which is not true? ARM is going to provide free cores from now on. No, just kidding. So Open Silicon, what we do is we integrate IP from different customers or for different customers, and we look at it from a system perspective. You know, an IP is not just a DDR5, but it includes also what is the package, what is the channel, what is the software that the customer intends to use. And when we talk about ARM, it's something that we have what we call a center of excellence, ARM Center of Excellence. We have integrated a number of ARM cores, the different ones, the multi-cores, the single cores. And one of the challenges that I see from our perspective, you know, Open Silicon is an ASIC integrator, and our business model is 3 parts. The first one is that if a customer has a spec, they come to us and we provide a part. The second one is that if a customer has an RTL and they want a part, we give them a part. And the third one is if the customer has a GDS2, then we can help to do the manufacturing of that part for them. So from that perspective, to us, cost is a big plus. It's a big issue. And when you think about integrating an ARM core, is basically we integrate it as a subsystem. So system has different pieces of it. One of them is hardening the core, providing the peripherals around it, having the firmware and the right software, and having that ready for a customer. So to us, cost is a big challenge, and our goal is to have first-time working silicon. So we look at many different aspects of integrating that particular CPU embedded core IP in our system.
Pascal?
Yeah. I'm Pascal Barioulet. I'm the managing director of Elsys company in the US, based in Santa Clara. So let me tell you more about Elsys. Elsys is a leading semiconductor design services company. We specialize in digital, analog, mixed signal, IC design. We have around 300 IC design engineers and design centers in Europe, in France, in Serbia, and also in the US. So we are providing complete semiconductor design solutions and also cost-effective design services from our design centers based in Serbia. The company there is named Elsys Eastern Europe with the green logo of there. And I'm representing Elsys Eastern Europe in the US. So we are working in different markets, providing solutions in automotive, in wireless, IoT, industrial, and consumer applications. So Elsys Eastern Europe has recently been selected as an ARM approved design partner, and we are here to help customers to make their product succeed in their targeted market applications.
Thank you very much, Pascal. Bogdan?
Okay, hi. So I'm from HDL Design House. We are a European design house with design centers in Greece and Serbia also. Serbia is a very small country, but apparently having many design centers recently. So we are like a 17-year-old company having approximately 160 engineers of all type design, verification, analog, backend. We are mainly providing services to the big companies, especially in the terms of verification, but also in the terms of the design, analog, mixed signal, and backend. So that's about it. I want to join to the discussion as soon as possible, so I'll skip promotion. Everyone knows this already. So we are ARM-approved design partner. We are having maybe like 30 engineers with the ARM-accredited engineer certificate. And thank you for ARM for that. You gave us a couple of very good weeks of teaching us on many stuff. So, yeah.
Oh, thank you for the commercial about ARM training as well. That's very welcome indeed. And finally, Ambar, please.
Hi, everyone. Nice to meet you all. So I'm the chief technologist at eInfoChips. For those who do not know eInfoChips, we have been in this business for 20 plus years. And what we do is essentially provide ASIC to FPGA design and verification and RTL to GDS2 services, as well as embedded software and software R&D services, as well as product engineering. So over these 20 years, we have had about 500 plus actual products that we have helped our clients deploy. And those products are right now, about 40 million plus are in actually deployment over our 140 years. So 140 countries. So this is actually quite an interesting thing to see that at every aspect of what we do, whether it be from RTL to GDS2, whether we are developing a proof of concept software, or whether doing a simple product engineering, ARM is there. So that was one of the reasons why we were very excited to join the ARM partnership. And the other aspect of it is that one of the things we're trying to get to, and maybe it might be a segue, is where are we seeing things go? So I just want to share with you, like one of the things is we don't have a crystal ball, do you? So the way I have looked at it is that, okay, is there anything new that we are doing right now that's like really exciting? And if I have been doing this, I can guarantee you that will go on for 3 years. So that's where I'm coming from. So what I'm seeing is on the software and the product side, a lot of AI applications are coming in, machine learning stuff. That's coming on and on and on and on. So that's one area. And on the ASIC and to GDS2 side, you're seeing low power becoming more critical, mixed signal stuff is becoming more and more critical, safety critical stuff is becoming critical. So these are the areas that we're moving towards. And my little desire is to say my core is verification. I'm a pinch hitter at everything, but my core is verification. And what I'm seeing is that verification as an industry doesn't have that. It has a lot of data, but not at the same level of data as other machine learning domains have. So I'm just trying to see a little bit more intelligence come into this machine learning, not just simple machine learning, but more intelligence. And I suspect that will happen over the next few years.
All right, thank you very much. A sort of excellent introduction and a lot of words that keep coming out. So let's get on with the discussion. I want to possibly leave some time at the end for questions from the audience if we have time. But one sort of question that keeps coming up is mixed signal. I think three out of the four of you mentioned mixed signal. So the first question I want to ask is what do you think will be different about the designs in 2 or 3 years' time compared to the designs we're doing today? Are we going to see more mixed signal? My guess the answer is yes. More heterogeneous processing? Is everything going to have a radio? Are we going to have to take more account of security solutions? Is power consumption going to become more important? So just perhaps we can start with Elias. What do you think is going to characterize the designs of the next 2 or 3 years? What's going to be the most important thing?
From a mixed signal point of view, or how I see it?
What do you think is going to be the most important?
So first time working silicon is one of our mission or priority, because we make money out of the silicon engineering. What that means is that when a customer comes to us and they're looking for a core that we provide, or they already have a particular core, and then we have to look at the peripherals to build that subsystem, and also the firmware software partition of that microarchitecture. It is important that all the pieces that go with that tie together, and we are able to find a cost-effective solution for that. An example, if I am in a market that requires high-end data conversion, or it requires very specialized sensors that require certain performance, right? And we go and look for a core from ARM with the peripherals. We have to make sure that either we have a production of the whole system in place, we have a test chip in place, so we know that when the actual customer, or when we provide or produce that in a full mass chip, that is going to work. So there is going to be some mixed signal data conversion because of all the sensors that we look at in some markets that will use also the embedded CPU cores. But the idea or the challenge that I see is how we can manage that cost when we look at the entire system of microarchitecting a subsystem within a system of all of these IP. So that's one of the challenges. And we'll see some mixed signal, yes. But I think we'll see the same ones, interface IP, core IP, some consumer IP, plus some of the mixed signal also.
So a large focus on cost effectiveness coming from you. Does anyone want to add to that?
I can add. In terms of trends, one of the things I'm seeing emerging, based on what we are seeing, is that the chips are kind of getting separated into two groups. One of them are these heavy kick-ass, compute centers with huge data networking, giant chips with the smallest process nodes. Low, power is an important thing, and those are the big companies doing this, and a lot of startups are working in that space. And on the other side, here's the sensor-based mixed signal design that are not huge, but they are kind of critical, and the analog and the digital parts have to work very well. So we are continuously seeing that trend emerging on the other side, where they are not looking at huge verification efforts, but the complexity of interaction is very hard to detect and get the design right first. At the first get is becoming more and more of a challenge. So I see a bifurcation of that. The other thing I'm seeing is the fluidity between a functionality between hardware and software. So because of that, what's happening is your hardware and software go either way. And being a verification guy, you cannot just say, okay, hardware will do this, software will do this, and tomorrow move the thing around. So therefore, you can see in the industry, you may have heard of the word portable stimulus. So that's why it's getting more traction, because what is happening is you cannot say what your system will do at a hardware software level. You have to raise the abstraction, say what you want, and then let it fulfill back again. So these are a couple of the trends I'm seeing happening, and I think they will get more traction over the next few years.
Okay, no, thank you very much. Some interesting points there. One thing you do mention is possibly the increasing verification challenge that we're going to see as hardware and software start to become slightly more integrated. Pascal, do you have any comments about increasing verification complexity and challenge?
Yes, so I completely agree with Ambar on his opinion concerning the complexity, the increasing complexity of the verification process. So there will be more and more smart connected devices, and I really think that innovation is going to be enabled and accelerated in products and services, taking the embedded intelligence to a whole new level. So I think companies will have to push the boundaries of what products can do. So meaning by that, they will have to be differentiated. So most of those devices will integrate lots of sensors, mixed signal parts, RF, CPUs, probably more memory capacity. So I will see definitely more digital analog integration. But as well, all those devices will generate a data volume far in excess of what can be easily processed and analyzed in the cloud. So I believe that in some cases, the intelligence will be shifted from the cloud to the edge. So meaning by that, requiring additional computational power on the edge. So both digital analog integration and also more diverse computational power.
Elias, you want to respond to that?
One comment. I think that so what has happened in the last 10 years that I've seen, when the whole third-party IP started, actually more than 10 years ago, we saw a lot of verification, in-house verification, a DDR protocol. You had a lot of engineers running a lot of vectors, make sure that you have your BFM models and everything else there in place. What has happened is that a lot of that has shifted to the IP vendor. So the IP vendor has to spend quite a bit of time making sure that the protocol and all this stuff is done. And probably at characterization time, ASIC people like us or the IP vendors will have to spend more time characterizing that particular IP at that time. But verification of an entire system is more of, okay, how do we connect this? And if there is some particular secret sauce RTL-wise that some customer wants to inject into that whole system, then they'll do it, and they'll do some verification on it. But I think that I see more and more subsystems being already verified through the IP vendors, and you're putting more of subsystems into one chip, and then connecting all of that. I think that's where intelligence is going to take more place.
Thank you. Just one theme that I possibly sense coming out here is a sort of downwards cost pressure on devices. You know, people want to design more and more devices. They want them more specialized. They want them more complex. They want them to do more stuff. But there's a downwards cost pressure on that. And as the devices become more complex, they become more and more difficult to do. So, I mean, Pascal, maybe you could comment on whether you think that's an area where design houses can really help the industry by making it more efficient and bringing specific expertise to drive costs in the industry down. Is that an area where design houses can help? Sorry, Bogan.
You mentioned
sorry,
Pascal.
I know it's
well, the pressure on cost is always there. Yeah. So, but in terms of let's say lowering the cost, I don't see this significantly possible right now. The complexity of the projects will definitely increase. And on the design side, usually we have like linear dependency on the number of RTL lines comparing to the bugs. But on the verification side, you usually see exponential effort in order to cope with this. And also the mixed signal verification is not helping this. It's actually making things much more worse. I think Cadence did some survey recently that first time not right silicon, maybe 50% was related to the mixed signal problems. So that's something, that's the problem that needs to be solved. We are engineers, so we solve problems. So, and yeah, let's say that there is a lot of issues along the way on this area. So, number of verification engineers needed, it's going to grow also exponentially. So we also discussed like hiring crisis. I think it's already there. So I don't see this is like, well, big companies are not admitting this yet, but engineers don't grow on tree. So this is another problem that we need to solve, and there is no quick solution for this. So. Mixing of verification also is, let's say, since it's already mentioned, it's very unique because you have to make a verification team and analog team work together. And we all know that analog engineers consider themselves to be like nobility from our world. And so it's very difficult to, let's say, join them together and work very efficiently.
So you're starting to make things sound very bad. We've got to do better chips that do more things with fewer people and fewer dollars. I mean, you're starting to make things sound very bad.
Could be that I'm already very old guy. I've seen a lot.
So you know, if we have to look to better methodologies and better tools and better IP to help fix that, what would you like to see the IP companies and the tools companies coming out with in the next 2 or 3 years? Pascal, may you comment on that?
Yeah. So recent studies have shown that over 50% of the development time is being spent on verification, and it's gonna get worse in the future. So
I'm not the only one.
I fully agree.
We are both from Europe.
More complex design, more mixed signal integration, more things to deal with. What I would like to see in terms of innovations or improvements is things related to the tools. Today, for larger design, the verification tools are not fully capable of running full design efficiently, and the elaboration time is too long. Rerunning a single test case may take 5 to 10 hours sometimes. So this is one thing, and in addition to that, there will be hardware, software, co-simulation, because now it's a standard request from our customers. And today we see also that the tools are often limited when it comes to software debug in verification environment. So we are expecting on our side improvements, innovations in the tools, especially in those used for the verification.
Okay, thank you very much. There's an awful lot of improvements that you're asking for there. Would anyone else like to come in on that, Elias?
Yep. So I don't agree with a lot of the things that have been said, and here's the reason why. When Open Silicon started back in 2003, I agree with everything they said because it was something different. It was hard. Implementing all kinds of IP blocks, mixed signal, digital was difficult because you didn't have a good flow and a methodology. And when you come from when you go and do certain methodologies with the processes and the tools, you come up with a flow and a methodology tried and true, through the years, to a point that, okay, you want first time working silicon. So if that vendor doesn't have ATPG models and doesn't have X, Y, and Z that we require in our process, our tool flow, then we cannot procure that IP. We cannot integrate that IP. When that vendor doesn't have the right documentation and we look at it, hey, we need X, Y, and Z, then we cannot take that IP. We cannot integrate that IP. So my thing is you have to develop a flow and a methodology. And many times analog mixed signal designers don't understand the digital aspect of it, don't understand the test aspect of it, and they don't have enough money or investment to hire their own people that understand this. So they expect customers or their own customers or ASIC integrators that procured the IP from them to help them do that. So I think the issue is that from a circuit design perspective, from a macro perspective, things have become more complicated, so they have to do more simulations. But at the end of the day, the integration part of it the test methodology part of it has to be there in place in a very systematic way. Otherwise, it's not going to work.
Ambar, you're nodding there.
Yeah,
come in.
so I agree with all of the statements, but I think the future is not as dark. Okay, here is the thing. Okay, so let's look at it. I mean, we have been facing this over and over again. Who is saying the chips have become easier to deal with? Every time I talk to this, every year I come with the chips are getting worse, etc. So what's helping us? What's letting us stay afloat? Well, here are a couple of things. Let's walk up bottom line. Okay, what can the IP designers do? Okay, to go back to my previous speaker, I mean, the more and more you can make it available to the end user, it's better. So do better encapsulation of various things your IP should provide. Okay, so today I know the vendors are trying that. So they are saying that okay, with this IP I will make it emulation compatible. Okay, with this IP I will have a lot of assertions and stuff packaged with it, so you can do better, formal verification. So I think the more and more encapsulation of all these things do, the better it is to integrate and do the systemic verification. Then as you go up and you're creating a system level stuff, okay, that's where having platforms which are SoC platforms, where essentially what you're doing is you're plugging in your specific IP and the rest of the stuff comes for free effectively through your previous generation devices, it makes it incredibly easier. So what happens is as we go into many of these places, they already have very razor thin margin. So you cannot really go take the price any further down. So where is the thing? So they try to reduce the NRE. So previously we used to say 6 months. Now they say better get it done in 3 months. So and yet we are being successful. The reason we are being successful is because we have learned a lot. We are asking the IP providers to provide us a lot. We have a good methodology in flow where things can snap back in better. And we have to continue doing that. The other thing, looking towards the future, that I'm kind of excited about, it may not happen, is that there's a so-called buzz about machine learning. Now remember, when we did like random stuff, why was constrained random useful? Because instead of directed test, constrained random came and gave you things that you hadn't thought about. That was the biggest value of constrained random, because it would create scenarios you couldn't have thought about. Formal is trying to really wring everything out of your design. But what will machine learning bring on top? Machine learning, what it will bring on top is what formal cannot do. Formal will only look at your design and try all kinds of scenario. Machine learning might add another angle to it, which even formal wouldn't have thought about. That's why I think, these trends that are coming, they should be happening. So I think it's not as bad. We as engineers or problem solvers, we'll figure out a way to do it.
It's very, very interesting to hear you say that. I mean, we've just had a session previous to this on stage from Rob Aitken, an ARM fellow, talking about machine learning and IoT. And one of the things that our CTO, Mike Muller, talks about a lot these days is using machine learning in ARM's internal processes to improve the way that we do engineering and improve the way that we can verify and deliver our IP. Does anyone else see machine learning playing a bigger and bigger part in the development of silicon devices?
I don't know. I'm still skeptical.
Mm-hmm.
So
you're going to wait and see.
Well, they promised us a lot in the past. So when I was a kid, they promised warp drive. So I don't know. So let's say and wait. But the process is very complicated, very creative. Mm-hmm. It's much more complex than driving a car, for which you do machine learning to gather the data. And so yeah, I would remain skeptical for some time.
Would you like to see it happen?
Oh yeah,
yeah, sure.
But this is another problem. Let's say
it's another show. Okay, sure. Elias, you would.
On machine learning. So when I was in graduate school, my roommate worked on a neural network. This was more than 30 years ago. And it's just recently that we see neural networks, CNNs and all of these blocks happening. I don't know if that's going to help on the RTL side. I think it's more of because you have to learn it, right? So you're going to spend time learn how the RTL works and how the application works. Are you going to spend all that time? Or is it going to be more of an application where the machine learning that applies to something more tangible that you can see that can help you do other stuff? I'm not sure about that yet, on the fact that you can use machine learning to improve your verification or your RTL, because it's like a chicken and an egg thing. So maybe it'll change.
Fair enough. We shall wait and see. Just to open up another sort of very topical, I think subject that's going to become very important. We're seeing an increasing awareness, not just in the industry, but in the consumer base, to be honest. The devices that are going to be connected in multiple connected networks, IoT devices, whatever, really need to have security baked in right from the start. It needs to start from a hardware basis, and it needs to carry through the software stack. Is the nature of building secure silicon systems something that you and your companies have given significant thought to? Pascal?
Yeah. So judging on the projects we worked on, we saw that the security problem will have to be tackled on all fronts. So meaning by that, first of all, in theory, so we have to get even better and faster encryption protocols. On the software side, we will have to apply protections on all kinds of potential attacks that can pop up on the internet. On the hardware side, also we need to secure more all the different communication channels. It could be on-chip communication with the interconnect. It could be communication outside of the SoC. And lastly, also data storage. So data storage needs to be encrypted and resistant to any potential data extraction attacks. So I really think this problem is split between hardware and software and should be solved combining both efforts. And also we have to have more cooperation between hardware designers and software developers. They have to know what they are doing in terms of verification and how the hardware works, and vice versa, of course.
So would you say it's a big strength to have the hardware engineers or the silicon designers and the software developers working in the same company and working on the design at the same time?
Yeah, because up to recently, these were almost independent processes. The software on one side and on the other side the hardware team. So I really think that we need to combine the effort on both sides.
Thank you. Bogdan, do you find this is something that your customers are asking for more and more?
Yes, they do, and it's coming. It's still Wild West, so a lot of things are still open. We see recently with this intrusion and everything else, but still I would like to, let's say, blame the software guys. And we can do whatever they want, and we can implement whatever encryption engine and everything, but it's up to the software guys to plug the holes. I mean, we can develop a lock for the door. If they don't use the key, it's not my responsibility. So yeah, you need to bring in software guys, and then you have to make sure that they are responsible to specify, to develop, and to
Absolutely, I agree with you. It's a whole system problem, and everything has to work together. But would you say that the right IP is available on the market to implement secure solutions, or are you looking for different or better or more IP in that area?
Well, currently it's like trade-off, because if you develop more secure, more closed system, then you cannot penetrate the market that much. You will become too close, and there is no setup standard for all the stuff that has to communicate in between. So that's why they're exploiting this weakness so far. So over the years, we will probably converge to a couple of protocols and standards, and the systems will become more and more secure. But it's not going to be something that we are going to see in the near future. So it's like a trade-off.
It's not going to happen overnight. It's not easy.
No, yeah.
But it needs to be solved.
Exactly. So it will be solved.
Actually, it's a very complex problem, and we can spend here the whole afternoon talk about security. So if you look at a mobile phone, you look at an app, and a secure app, there is about 10 layers of security that you have to review it. From a chip perspective, there is a lot of companies, IP providers that provide IP, secure it through the boot code, secure it through various methods. At least I know 5 different IP vendors that we work with that can provide security IP. But then you have to look at you have to send information through an HTTPS TCP protocol. You have to look at the full stack. You have to look at the front end, the back end. If you have an application that resides on AWS, Azure, any of these, there's other things that you have to worry about attacks, right? For instance, Amazon spent many millions of dollars making sure that their website or their access is protected. I mean, if you look at, especially those that know about the healthcare industry, healthcare is a very HIPAA-oriented, privacy secure type of platform, but you still have to use it. People have to get access to their information. So we have IP for chip or to be integrated in an RTL. There's a lot of things that are happening right now. We have encryption mechanisms and encryption algorithms that are being used more and more. But in terms of security, you have to look at it not from your chip. If you have an access point, the moment you have an access point, you already have a fault in your security because anyone can hack into that access point. So you have to look, like I said, there's about 10 layers of security from a system perspective. And we do have, things are improving more. I see more and more IP security solutions in the IP space.
Well, thank you. So, Ambar.
Yeah, I just want to, I'm listening rapidly. I think I would like to add one more angle to it. Like, there is not a single silver bullet. You have to address security at each and every level. So that's one thing which I think we all will agree. The one other thing I think I would like to see more is application of formal technologies in terms of detecting information leak and stuff like that. And that could be very interesting at a system level to apply some formal technologies to sort of detect security. And again, that won't be the silver bullet, but it will be a nice bullet. So,
as you say, no silver bullet. It would be nice if we had one.
Yeah.
Just want to give the audience the opportunity to ask the panel any questions while they happen to be here. I'll bring the microphone over if you want to ask a question.
Thank you so much, Shubhankar Basu from Global Foundries. Nice discussion, by the way. I think my question is more, so there is a trend right now for more and more system-level designs, right, and faster time to market. Small companies trying to come up with system-level designs which would fit in either a IoT segment, consumer level, or maybe something more complex like machine learning. Question is, and you guys have answered various questions in terms of verification being offered at the chip level, analog and mixed signal, digital, etc. Software plays a huge role now. Software and hardware, right? It's not only a one ASIC or, it's multiple stacks of things. Vertical integration is happening for the solution. Do you have any vision of how integration at a system level is happening beyond? And there's a lot of things we already have over the years in ASIC design or IPs. How much or when do you think this will be offered across the scale to enable this kind of faster time to market, system level implementation while ensuring security or verification kind of techniques?
Thank you for your question. Does anyone want to?
I can start. Basically you have to think of it as any other problem. You have to address the right problem at the right level. So for example, you should not be checking IP level bugs at a system level. So you need to have a bottom to top understanding of where this product is going. And then you have to identify, okay, what is it that I'm verifying at what level? So you have to have the very clear picture of that. So if you're talking about security, now security, again, as I previously said, that appears at every level. So now you have to map security at each level and see what's going. Software, I said software and hardware become more and more fluid. So now what happens is performance is a consideration, and people are doing all kinds of architectural analysis. They are using transaction level models to figure out what will work. So I think you can get a long way there, at least 80 to 90% there, if you have captured the right problems at the right level and then address them. Maybe there's more. I just thought that's important to understand that.
Actually, I look at it from the other way, not from bottom up, but from top to bottom. And the way that we have implemented already at Open Silicon is that you look at it from aspect to part, right? Someone comes with, hey, I want to have an IoT, or I want to have something else that can do vision learning or whatever, right? Well, what exactly do you have? Do you have a legacy code? What kind of, is it C compile or not? If you have legacy code in firmware, and you have a specific embedded CPU or some core, then you know that it's going to be challenging porting that into your new application from scratch, right? So you have to port or continue that train on a core that may be more advanced or have better performance. Then you look at it, what subsystems do you have, right? I have this. These are all the peripherals that I want to talk to. How do you write that code? What kind of firmware and where is your middleware stack at? Okay, what do you use for? And then you look at, okay, now that we have this, okay, what other things do I apply that goes into that chip, right? And then eventually say, okay, now that I have the or the system architecture, I have my subsystem, and then now I have my other, what I call peripherals, but in the data flow place. How do I put all that together? How do I verify that all together? And what tools do I have to make that happen? And if I have legacy, what do I do? Do I open a new front of, hey, I want to have a new blank sheet of paper to pick a CPU core or not? And so that flow is the one that we have successfully used at OpenSilicon to implement this kind of designs from that perspective.
Just something else. So concerning a shorter time to market, so I really think that specialized design houses like us, like Elsys, can really help on that topic. We can help customers solve these challenges. So specialized design houses have already SoC design experience, sometimes design reference platform they can use for other projects, and they can benefit from previous experience, and also they can provide access to a network of required partners for their designs. So I really think this is a way to use companies like Elsys or us to shorten time to market, and also to be more cost effective than any small company doing a development from scratch.
No, thank you for that. Bogan, any closing remark from you?
Yeah, well, now that we mentioned this shortening time to market and everything done by the in-house, we have this discussion even before this talk that actually what will happen with the designs done in the in-house, let's say like core designs versus the outsourcing whole designs to the design houses. So this is it's possible to have shorter time to market if you give everything away to the outsourcing company, but it's actually not entirely possible. So there is a limit to that. And some of the core stuff you want to keep for yourself, and then you have other things popping up as a problem. So regarding time to market, we are already fast. Mm-hmm. It's the problem that we have, many chips in parallel working on. So the demand for the market is actually increasing. So
yeah, just one comment on this. So companies have to keep their focus on their core expertise, but they can outsource or subcontract the non-critical parts. That's what I meant previously.
Thank you very much. I think we probably ought to be winding up there, but I'd like to join me in thanking the panel very much for the time that they've devoted to answering the questions and to giving us their expertise. Thank you very much, guys.
Thank you, Chris. Thank you, guys.